All right. All right. Good morning, students. How are you all? I hope you all good. And come and join live as early as possible, all class 11 students. And now, today we are going to discuss example number 2 and 3, and if possible, exercise number 4.1, second, third, fourth, and fifth. Okay? Right. So let us start our class, whether you will come or not. Take time, these all I don't want to think about it. Let me start. Let us close our eyes and we'll start our class. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Right. So now here, for example number 2. Hmm. So prove that P of n is 2 power n is greater than n always. So here the statement P of n is 2 power n is greater than n. This is what they given, and like this they given everything is easy to solve. So this is what our statement they given according to principle of mathematical induction. We learned what? So this we are discussing chapter number 4. Chapter 4 PMI, Principle of Mathematical Induction. So this is what the statement they given, and they said that it is proved by using the principle of mathematical induction. So what I need to do is, so you already know that what is principle of mathematical induction. So first n is equal to 1 to k, n is equal to k plus 1. First you need to prove, given statement is prove for n is equal to 1. Next n is equal to k, next n is equal to k plus 1. Okay. So now what I do here is, first whichever the statement is that gives us P of n so that all three parts complete, and give gap here down so that it is possible to write a class from 1, 2, and 3. It is proved. So now first let n is equal to 1. So now take LHS. LHS is equal to here 2 power n. RHS is equal to here n. So now check carefully now. 2 power n means 1, substitute 1. RHS n means 1. So 2 power 1 is nothing but 2. This is equal to 1. So 2 is greater than 1 or not. So right here LHS is greater than RHS. So here greater than symbol came, so that here also greater than is there. So LHS is greater than RHS. Therefore, we can write it as P of 1 is true for P of n, equation number 1. Now, let n is equal to k. P of k is true for P of n, where k is any positive integer. Any positive integer. That part I am going to write down. So what we need to do in the second step, wherever n is there, substitute k. So P of k such that 2 power k is greater than k. So now P of k, what you got? 2 power k greater than k. So this gives us equation number 2. Okay. So then easy purpose what I will do here, just observe carefully. So I want to prove now what? Let n is equal to k plus 1 to prove P of k plus 1 is true. What I do? Multiply equation 2. For this different, I said in the second one will be the different. So multiply this equation 2 with 2. with 2. So when you multiply this equation 2 with 2, what will happen? So 2p of k plus 1 here, this k plus 1 only we are finding, but no need to write that, only go for problem. So what I'll do here, it is to multiply with 2, 2 power k into 2 greater than 2k. So here nothing is there, means 1 a power m into a power m. So listen here, a power m into a power m means a power m plus n. Apply that formula and write answer. So 2 power k plus 1 is greater than 2k, means we can write it as k plus k. Okay? So we can write it as k plus k. So now 2 power k plus 1 is greater than k plus k, means added k plus k, also k less than the k plus k. That was the reason we written as greater than k plus 1. So now observe carefully, wherever n is there, there we got k plus 1 or not. So here it is n is there, k plus 1 got, and here also n is there, k plus 1 is there, and here k plus k is there. So now what we understood here, n is equal to 1 substituted, it is true happen. Then n is equal to k substituted, that time only n plus k required. So then k plus 1 means wherever n is there, there you need to get as k plus 1. So that's what 2 correct. So therefore p of k plus 1 is true for p of n. This gives us equation number 3. So therefore, from 1, comma 2 and 3, P of n is true for all natural numbers. Okay? So here P of n is true for all natural numbers. So where is your friends? Till now not reached. So 11:10 it was started and only one student was watching. Who is that student? Also don't know. Where is this Sahil and all? Where they went? Whether you got my message or not. So I don't know whether you all got my message or not. So kindly inform whoever is present. I don't know your name. So kindly inform to your friends, let them come and join. That is about your example number 2. And now we'll go for example number 3. Easiest chapter and not going to come inside this time for you. Right. Anyways, this is what the problem. Previously coming, and how can I say you are coming? Right. Now, problem number 3, that is example 3. So, example 3, they given us prove that 1 upon 1.2 plus 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 upon 3 into 4 plus and so on plus 1 upon n into n plus 1, that is equal to n upon n plus 1. This I need to prove. And this is also same simple. So first always whichever given think as P of n. So after that what we need to do when you get the P of n? So let n is equal to 1. Take n is equal to 1 and then substitute. So first LHS, what is your LHS? 1 upon n into plus 1. And what about anyhow your RHS also here only also. So LHS plus substitute n is equal to 1, 1 upon 1 into 1 plus 1. 1 upon 1 into 1 plus 1 is 2. So 1 upon 2 you are going to get. So then go for RHS. When you go for RHS, what is your RHS? N upon n plus 1. So n is nothing but 1. We took 1 upon 1 plus 1, that is 1 upon 2. So now from this you found here LHS also you got as half, RHS also you got as half. So then therefore LHS is equal to RHS. So at last I'll write here therefore. So here LHS is equal to RHS we got, therefore P of 1 is true for P of n. Okay, this gives us equation number 1. Now let n is equal to k. P of k is true for P of n for any. So for k is any positive integer, or we can write here it is where k is any positive integer. So k is we are thinking as any positive integer. What we need to do is simply wherever n is there, just substitute k. So now p of k is such that 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus and so on plus 1 upon k into k plus 1 is equal to k upon k plus 1. Okay, so we'll write in this way what we done here. Wherever n is there, just substitute k. So here n into n plus 1, so that k into k plus 1, and here n upon n plus 1, so that written here k upon k plus 1. So once if you write this is your equation number 2. So because I am thinking here p of k is true for p of n, where k is any positive integer. So then p of k you got. So k plus k upon k plus 1 you got. If I want k plus 1 as a true, I need to prove n plus 1 I need to get answer k plus 1. N plus 1 means I need to get as k plus 2. So k plus 1 upon k plus 2 if I prove, then it is true. So for that purpose what I will do, just observe now, let n is equal to k plus 1 to prove P of k plus 1 is true. What I'll do, just check. Only k plus 1 term add for this LHS. So that means P of k plus 1 such that 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus and so on plus 1 upon k into k plus 1 plus. So one more term you have, the term will be the k plus 1 term. So now 1 upon wherever k is there, what you need to write k plus 1. K plus 1. And here again k plus 1 means k plus 2. You got now? So from here to here, did you find anywhere in this? So you found here equation 2 is that. Check carefully 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus and so on plus 1 upon k into k plus 1 is nothing but k upon k plus 1. So this full I can write it as k upon k plus 1. That is plus 1 upon k plus 1 into k plus 2. So now observe carefully what is LCM for both. Both LCM is k plus 1 into k plus 2. Okay. So now here only k plus is there, means what is not there? K plus 2 is not there. So that k into k plus 2 plus here k plus 1, k plus 2 both are there, means 1 means 1 only you are going to get. So now what I need to just carefully observe now. K into k square plus k into 2, 2k plus 1 upon k plus 1 into k plus 2. K square plus 2k plus 1 is nothing but k plus 1 whole square. So write the k plus 1 whole square upon k plus 1 into k plus 1 plus 1. So now k plus 1 and that square will get cancelled. So you get as k plus 1 upon k plus 1 plus 1. So you are going to in this way. So now check carefully. Wherever n is there, here k plus 1 came earlier And next also n is there k plus 1 plus 1. So that therefore here I am writing therefore p of k plus 1 is true for p of n. This is your equation number 3. So first what I need to write, therefore from 1, 2 and 3, from 1, 2 and 3, right here it is p of n is true for all natural numbers. Okay, so you all observe this, totally observe, and once you can check this out, but if you are having any doubt you can ask me. You just concentrate this. So now I give for you some 60 seconds. Within that 60 seconds, you can understand it. And if you are not able to understand, you can ask me so that I can help you out. Okay? Right. Okay, I hope you all observed that, and let's move on to the next. Mine it was cut so that I could not able to find whatever you will write the comments, and I'll go for now your exam exercise problems. So your comments also now I could not able to find. You just concentrate and learn it. So now we are going to the exercise problems. Okay. So now we are going to solve our exercise problems. So exercise number 4.1. We already discussed first problem. Now today we are going to discuss second. So in this they given us prove that by using principle of mathematical induction, below statements are true. So 1 cube plus 2 cube plus 3 cube plus and so on plus n cube is equal to n square n plus 1 whole square upon 4. Actually, they given n into n plus 1 upon 2 whole square, but I was written that square was given to both the terms and written as like this. So n square into n plus 1 whole square upon 4. So now this I need to prove as a true. So this also same method. So first let this will be the P of n, and now first part. So what I need to take first part in this? So let n is equal to 1. So then what should be our LHS? LHS is equal to n cube. Only n term we have to take, we cannot take this out. So now 1 cube is equal to 1. Then RHS take. So RHS is n square into n plus 1 whole square upon 4. Then 1 square, 1 plus 1 whole square, 4. 1 square is 1, 1 plus 1, 2, 2 square is nothing but 4, then upon 4. So then 4 and 4 get cancelled, you get answer as 1. So from this both are equal, therefore LHS is equal to RHS. P of 1 is true for P of n. Give equation number 1. So then we go for second part. Let n is equal to k. P of k is true for P of n, where k is any positive integer. Okay. So then what I'll do after that, check carefully everyone. So now here positive integer is set, and wherever n is there in this place, just keep as a k. So and so on plus k cube is equal to k square, k plus 1 whole square upon 4. This is your equation number 2. Okay. So now what I'll do is let n is equal to k plus 1 to prove P of k plus 1 is true. So what I will do? So I will do is only extend here one k term. So means what I can do here, P of k plus 1 such that 1 cube plus 2 cube plus and so on plus k cube plus 1 term increase a k plus 1 cube. So why we are increasing, and those are we discussed in the first program in the first class. So now here 1 cube, 2 cube plus and so on k cube plus k plus 1 whole cube. So after writing that, what I need to do, check carefully. Here to here we already found in the equation number 2. In equation number 2, this is nothing but k square k plus 1 whole square upon 4. Write that. K square k plus 1 whole square upon 2 plus k plus 1 whole cube. Nothing is there means upon 1. So LCM take for both. For both LCM is 2. So now we can write here k square k plus 1 whole square plus. Can you write this k plus 1 whole cube as k plus 1 whole cube as k plus 1 whole square into k plus 1. But LCM when you take 2, then this becomes as multiplied with 2. If you don't know, 1 into this as it is, 2 into this as it is, right? Then 2 ones are 2. In that way, you can solve. Means if A by B plus C by D is there, first you need to multiply these two and then these two multiply. So AD plus BC upon LCM is BD. So apply this method. Okay. So now that is equal to in both k plus 1 whole square is common that k plus 1 whole square common. Then what you get k square plus 2 into k plus 1. 2 into k plus 1. That is upon 2. Okay. So 2 into k plus 1 upon 2. So now let me check. Sorry, it is 2 or 4. See, here it is 4 and I was written here 2. This is 4 and 4 and here also 4. Now just multiply and get answer. K plus 1 whole square into k square plus 4 into k, 4k plus 4 ones are 4 upon 2. This you can write k plus 1 whole square and this you can write k plus 2 whole square. Check that and tell to me. K plus 2 whole square means k square, then 2 square, nothing but 4, 2 into A into B, 2 into 2, 4, and B is k, so that 4k. Here, k square plus 2 into k into 2 plus 2 square. That means k square plus 4k plus 4. Okay? So whenever k square plus 4k plus 4 is there, we can write k plus 2 whole square. Now check carefully. Wherever n is there, I need to get as k plus 1. N is there, k plus 2. N plus 1 means k plus 2 you need to get. So that k plus 2 you got. Still you want to write in some other way, write that k plus 1 whole square into k plus 1 into k plus 1 plus 1 whole square upon 4. Again this mistake. So upon 4 upon 4. Okay. So that is you are going to get. After getting this, what we need to write? Therefore, P of k plus 1 is true for P of n, that is equation number 3. So when you write this, write therefore from 1, 2 and 3, P of n is true for all natural numbers. Okay, in this way you have to solve second one. So I could not able to find your doubts also. So what you do is just comment on the comment section of this YouTube session so that later I can help you all in that. Okay, right. Let's move on to the next problem now. Because wasting time is a crime. So let me complete this part. Wherever you get the time, just send your comments in the comment sections so that at least after offline video then I can help you out. Because I'm not finding anyone's comment in this. I'm unable to find how many students are present also. Okay, right. So next one, it was our third question. This question is very important, and many times they were given in your examination. Kindly concentrate because this question first given statement you have to change it to the required statement. Then we have to solve. Okay. So now sum of before going to this, you need to remember this sum of all natural numbers is equal to what is you have formed 1 plus 2 plus 3 plus and so on plus n is equal to n into n plus 1 upon 2. So sum of n natural numbers is n into n plus 1 upon 2. That is formula, remember it. So now what is our statement? P of n 1 plus 1 upon 1 plus 2 plus 1 upon 1 plus 2 plus 3 plus and so on plus 1 upon and so on plus 1 upon 1 plus 2 plus 3 plus and so on n. So that is equal to 2n upon n plus 1. So you already know only this part I will take here, only this part, so that you can understand it what was there. So only this part take. So we'll write here 1 upon 1 plus 2 plus 3 plus and so on n. So now 1 upon 1 plus 2 plus 3 plus and so on n is nothing but what is your formula? N into n plus 1 upon 2. Right here n into n plus 1 upon 2. Denominator goes to the numerator. So that 2 upon n into n plus 1. So instead of this step, we will write that as 2 upon n into n plus 1. Okay. So you just concentrate in that place. So now what I need to write? In this place, you have to write 2 upon n into n plus 1. Okay? So you can write that. So P of n such that 1 plus 1 upon 1 plus 2 plus 1 upon 1 plus 2 plus 3 plus and so on plus 2 upon n in n plus 1, that is equal to 2n upon n plus 1. So now you got our required statement. Then we need to solve our board. So it is very easy one. So you need to concentrate. That's it. If you are concentrated, it becomes as easy. I think some shading was there here. So now it was good. Yes. Now it was okay. So that is about it. So now what I need to do? Concentrate carefully, everyone now. So now, same manner, let n is equal to 1. Then LHS take 2 upon n into n plus 1. That is equal to 2 upon 1 into 1 plus 1. That is 2 upon 1 into 2. 2 get cancelled, you get answer as 1. And then RHS 2n upon n plus 1. So 2 into 1 upon 1 plus 1, that is nothing but 2 upon 2, that is nothing but 1. Therefore, LHS is equal to squares. So we can write now, therefore P of 1 is true for P of n. This gives us equation number 1. And second, what I can write now here, let n is equal to k. P of k is true for P of n where k is any positive integer. So we'll write this first. Then, when just this whole statement you have to write, but wherever n is there, you have to write as a k. So now write as p of k such that 1 plus 1 upon 1 plus 2 plus and so on plus 2 upon k into k plus 1, that is equal to 2k upon k plus 1. This gives us equation number 2. Now, let n is equal to k plus 1. To prove P of k plus 1 is true. So to prove P of k plus 1 is true, what I need to do? So P of k plus 1 is true if I need to prove. So this statement as it is you have to write, that is P of k plus 1 such that, because here k plus 1 upon 1 plus 2 plus and so on plus 2 upon k into k plus 1 plus one more term you have to add. Okay, so that is 2 upon k plus, you need to write as k plus 1. So right here k plus 1. K plus 1 means what I can write k plus 2. So right here it is k plus 2. Okay, so here n is equal to k plus 1 we are substituting, so that wherever k is there, that place another term. Next term we are writing here. So each place 1 you need to add. Next term means one term need to be added. So that is also, remember, you need to add for the k only. So now here to here you found in which equation? In equation number 2. So what is in equation number 2 that? So this full is nothing but 2k upon k plus 1, right? That 2k upon k plus 1 plus what is left now? 2 upon k plus 1, k plus 2. 2 upon k plus 1 into k plus 2. Here since from equation 2. Okay? So after writing this, what we need to do? Take LCM as k plus 1 and k plus 2. So now we can write here k plus 1 and k plus 2. So after that, what we need to do? Now you all coming. After half an hour, everybody was coming and joining. And kindly remember that your time is at 11. 11 means 11 to 12 you have to come, right? So I was really surprised with your late coming. But it's okay. So concentrate, but I don't remember, I don't want to wait for you all. Whenever class 11 I said means I will start at 11 and I'll end at 12. So you all go for offline video and learn it. Okay, no problem. So you all go through the offline video about today's topic and send to me what is your answers. Whether you are understood or not, you got any doubts or any problem, that you can, okay? See, this is what Sahil, again and again, I don't want to get any trouble about that your other teachers' timings. So inform to your other teachers that your math class is always from 11 to 12. It is from 2 months on the same only, and now he is coming and changing. It's not good, right? So inform to your teachers that. Okay, right. So now here we'll write this part. Just concentrate now. 2k k plus 1 is there, which is not there, k plus 2 is not there, so that right here k plus 2 plus, so now k plus 1, k plus 2, both are there means 2 into 1. So now we can write this as 2k into k, 2k square plus 2k into 2, 4k plus 2 upon k plus 1, k plus 2. Now, In all 2 is common. When you common 2, k square plus 2k plus 1 upon k plus 1 into k plus 2. You already know that k square plus 2k plus 1 is nothing but k plus 1 whole square. If you don't know, concentrate here. K plus 1 whole square is equal to k square plus 2k plus 1. Okay, so instead of k square plus 2k plus 1, we can write k plus 1 whole square. So now I am writing here k plus 1 whole square. So 2 into k plus 1 whole square upon k plus 1 into k plus 2. So now k plus 1 and that square get cancelled. Okay. So you refresh, Sahil, you refresh so that it is going to be clear your words. So now here k plus 1 is square written down and k plus 1 get cancelled. After getting cancelled, what you are going to get in this? So you are going to get here 2 into k plus 1 upon k plus 2. K plus 2 can write it as k plus 1 plus 1. Now check carefully. So if I need to prove that k plus 1 is true, so what I can do if I want to prove k plus 1 is true, wherever n is there, I need to get as k plus 1. And wherever n plus 1 is there, I need to get as k plus 2. Check carefully here. K plus 1 is there, k plus 2 also is there. So that it is proved. So at last, therefore, P of k plus 1 is true for P of n. That is equation number 3. So at last, therefore, from 1, 2 and 3, therefore from 1, 2 and 3, P of n is true for all natural numbers. Okay. So understand this. And still, if anyone having any doubt, you can ask me. So refresh it and check Sahib so that you can know that whether it is clear or not. Okay. So according to me, everything was clear. If you want little changes also, I'll make now. Right. So let me keep for your purpose. So I hope you all are able to find everything as fine method. Right. So that is about your problem number 3, and let's move on to the problem number 4. Today you all very late, so which I could not expect from you all. Right. So last minute you all came. I don't know how can I help you all now. Anyhow, when you get if you get doubts, you can ask me in your through WhatsApp so that I can help you, or you can comment on this YouTube comment section so that I can help you. And one more important thing, remember carefully, if anyone is needy to learn, say some people are unable to pay for, tuition fees and those all. So such kind of people, let them come and learn. The poor people who are is there. Actually, this channel was started for the poor people purpose. So who are unable to spend money for those, so let them come and join. So inform to your friends so that let them come and learn mathematics from this channel. All right. So that at the same manner, so inform to your friends that you have about our school facilities and all also. Okay. So that let them come and join if possibility is there. So now we go for the next one, that is problem number 4. By seeing, these are very difficult, but when you are solving, it becomes as very easy. So now here it was 1.1 dot 2 dot 3, that means 1 is multiplied with it, 2 is multiplied with 3 plus 2 dot 3 dot 4 plus and so on plus n into n plus 1 into n plus 2 is equal to n into n plus 1 into n plus 2 into n plus 3 upon 4. Okay. So you all refresh or not? So if you are refreshed, just concentrate here. This is what your statement. So first, let n is equal to 1. Substitute now. LHS place n into n plus 1 into n plus 2. So substitute wherever n is there. 1 into 1 plus 1 into 1 plus 2. 1 into 2 into 3, that is 6. So same method RHS also. N into n plus 1 into n plus 2 into n plus 3 upon 4. So we can write here it is 1 into 1 plus 1 into 1 plus 2 into 1 plus 3 upon 4. That is 1 into 1 plus 1 2, 1 plus 2 3, 1 plus 3 is 4 upon 4. 4 get cancelled, 2 3s are 6. So 6 you are going to get. So LHS is equal to RHS. Therefore, LHS is equal to RHS. Therefore, P of 1 is true for P of 1 is true for P of n. Equation number 1. Now go for your K. Let n is equal to K. Where P of K is such, P of K is true for P of n, where K is any positive integer. Positive integer. Then what I need to do? Wherever n is there, I need to write as k. So P of k such that 1 dot 2 dot 3 plus 2 into 3 into 4 plus and so on plus k into k plus 1 into k plus 2. So we are writing here 1 into 2 into 3 plus 2 into 3 into 4 plus and so on plus k into k plus 1 k plus 2. That is equal to k into k plus 1 into wherever I is there, just substituting k plus 2 into k plus 3 upon 4. For k plus 1, I want to prove as a true k plus 1, k plus 1 plus k plus 2, k plus 2 plus k plus 3, k plus 3 plus k plus 4 I need to get. Okay. So this gives us equation number 2. Now let n is equal to k plus 1 to prove P of k plus 1 is true. So what I need to do, just carefully observe now what I will do. So write this part as it is, but write next to term also. So now that is P of k plus 1, 1 into 2 into 3, 2 into 3 into 4 plus and so on plus k into k plus 1 into k plus 2 plus another term, right? So another term means wherever k is there, add 1. So k plus 1 is there means k plus 2, k plus 2 is there means k plus 3. Okay? Now here to here, this part already you found here. Substitute that value. When you substitute k into k plus 1 into k plus 2 into k plus 3 upon 4 less. So as it is this part, right? K plus 1, k plus 2, k plus 3. Nothing is there means upon 1. So take LCM as 4. K into k plus 1 into k plus 2 into k plus 3 plus 4, because LCM is 4, that's what 4 is multiplied and write my one. K plus 1, k plus 2, k plus 3. Now observe carefully in both places k plus 1, k plus 3, k plus 1, k plus 2, k plus 3 is common. So write that as common now. K plus 1 into k plus 2 into k plus 3. Then what is left? K plus 4 upon 4. So whichever I want that k method, n plus k plus 1 came, n plus 1 means k plus 2, n plus 2 means k plus 3, n plus 3 means k plus 4. So all the places k plus 1 got. So therefore, P of k plus 1 is true for P of n. Okay, so at last we'll write this is equation number 3 from 1, 2, and 3. P of n is true for all natural numbers. All natural numbers. In this way, for each and every problem, same procedure only. First, n is equal to 1, you need to prove. That is, LHS is equal to RHS. If it is proved, then go for P of K. P of K, we need to think as true, and then P of K plus 1. By using the P of K, we have to solve the P of K plus 1. So, once the P of K plus 1 is solved, in it, wherever n is there, then K plus 1 comes, then it is true. So then we can write it as from 1, 2, and 3. P of n is true for all natural numbers. So that is what we are going to write. So more than that, we cannot do anything in this. So that is about your 4 problems. And one more problem we are going to discuss once this is finished. So we are going to, I'm going to leave you. Okay. So fifth problem we are going to discuss. Then I will leave you all. And it was very easiest one. The fifth also easiest one. So by seeing problem, don't think as a difficult because it is very easiest one. By solving it is very easy. By seeing sometimes you feel as very difficult. So practice. This is the one chapter which was very easy by practicing. So after practicing, you'll find this chapter is dead easy. So let me check now. So your fifth problem, the statement is given as 1 into 3 plus 2 into 3 square plus 3 into 3 cube plus and so on plus n into 3 power n is equal to 2n minus 1, 3 power n plus 1 plus 3 upon 4. Very simple this also. First, let this is your fifth problem in the exercise. Let n is equal to 1. So then LHS take n into 3 power n, 1 into 3 power 1, so that 3. So that is RHS, go for RHS now. So that is 2n minus 1 into 3 power n plus 1 plus 3 upon 4. So substitute n plus 1, 2 into 1, 1, 2 into 1, 2, minus 1, 3 power 1 plus 1 is 2 plus 3 upon 4. 2 minus 1 is 1. 3 square is nothing but 9. 9 ones are 9. 9 plus 3, 12. 12 upon 4. 4 3s are 12. So that 3. LHS 3, RHS also 3. Therefore, LHS is equal to RHS. So right here it is therefore LHS is equal to RHS. Therefore, P of 1 is true for P of n. Equation number 1. So your first one done. Then let n is equal to k. So we need to think n is equal to k. What happened? Words are not clear. So you have to inform beginning only now. Okay, now check carefully. I'm going to keep again changing those all positions. Let you all check and inform to me what was the problem in this. Okay. Now again I'm keeping this. Let me keep. All right. So I hope now it is clear. Okay, I hope now it is clear. Once check and inform to me. If it is clear, then we can go for it. Fastly. Okay, let me continue this and then later you can check and inform to me that. So let n is equal to k. So that what we need to do? Let n is equal to k and we are taking p of k is true for p of n where k is any positive integer. Okay. Then wherever n is there, substitute k. So now everything is clear, right? So you check and inform to me because now change that. So P of k such that 1 dot 3, 1 into 3, 2 into 3 square, 3 into 3 cube, plus and so on, plus n into 3 power n. So n plus I need to write as k. K into 3 power k. So that is equal to 2k minus 1, 3 power k plus 1 plus 3 upon 4. Check. I also check the quality of video, so that is okay. Check 1080 you can go 1080p, so that you are going to get clarity was nice. So still for your purpose I can keep right. So refresh it. I think you are able to get. I'm finding it was clarity is good, but you can check or you can go for the offline video. Okay. So now once if it is completed, this give us equation number 2. So this also finished. Then let n is equal to k plus 1 to prove p of k plus 1 is true. To prove p of k plus 1 is true. So to prove that, what I need to do, one term I need to go into extend. So what I'll do here, p of k plus 1 such that 1 into 3 plus 2 into 3 square plus 3 into 3 cube plus and so on plus k into 3 power k. One term need to extend means what we need to do. So wherever k is there, write plus 1. So k plus 1, 3 power k plus 1. And here to here, this part you already found in the equation number 2. Let's substitute it. 2k minus 1, 3 power k plus 1 plus 3 upon 4 plus k plus 1 into 3 power k plus 1 upon 1. Here since from equation 2. By using this equation 2, I was substituted this full part as that. Okay. So now at last what I need to do here is this is equal to, so LCM, take LCM as 4. So 2k minus 1, 3 to the power of k plus 1 plus 3 plus, here it is k plus 1. So here 4 need to multiply 4 into k plus 1, 3 power k plus 1. So here 3 power k plus 1 is common in these two terms, just common it. When you common that, what you are going to get? 2k minus 1 here, and here these two multiply and write 4 into k, 4k, 4 into 1 plus 4. And here plus 3 is there, as it is that plus 3 upon 4. Now 3 power k plus 1. Now here 4k plus 2k, 6k plus 4 minus 1 plus 3. That is plus 3 upon 4. Now 3 common in these both. then 3 power k plus 1 into 3, that is nothing but 3 power 1. So 3 2s are 6, 3 1s are 3. So 2k plus 1 plus 3 upon 4. And then still, when you simplify this, you can write this is equal to 3 power k plus 1 and 1 k plus 2. K plus 2 got, so here also n plus 1 is there. That means if I want to write here k plus 1, what you get?